Before going to the next type of problem under the normal distribution, let us discuss few important points. Probability that z takes the values less than z1. Since our z is a real variable and when it can take any value which is less than z1 means it can take any value between minus infinity to z1. That is, consider it as minus infinity to 0 first, then it is 0 to z1. And already we know that area bounded by z is equal to minus infinity to 0 is 0.5, and we'll consider this area bounded by 0 to z1 as it is. And when it is 0.5 plus a positive value, obviously the value is always greater than 0.5. Now, in place of this z1, if it is minus z1, then what happens? When it is minus z1 and our z can take the values which are less than minus z1, then it is between minus infinity and z1. And now to find out this, first we have to find the area bounded by minus infinity to 0. In that, next we have to subtract the area bounded by minus z1 to 0. And we know that the area bounded by minus infinity to 0 is 0.5. And in this 0.5, we are subtracting the value, that is area bounded by 0 to z1, which is a positive value. So, when it is 0.5 minus a positive value, obviously we'll get the answer as a value which is less than 0.5. Now, based on these two, we can consider probability that z takes the values between minus infinity and z1. If the value is less than 0.5, then we can consider our z1 as negative. And if the value of p of z is greater than 0.5, in that case we can consider our z1 as positive. Or we can consider this as, if our z1 is a negative value, then in this case, our p of z value is less than 0.5. If our z1 is a positive value, then probability that z takes the value between minus infinity to minus infinity to z1 is greater than 0.5. Similarly, when z takes the values greater than z1, that means it is from z1 to infinity. That is area under the standard normal curve bounded by z1 to infinity. And to find this, first we have to find out the area bounded by 0 to infinity. In that, let us subtract the area bounded by 0 to z1. And area bounded by 0 to infinity is 0.5. In that, we are subtracting the area bounded by 0 to z1, which is a positive value. So, obviously, we are going to get the answer as a value which is less than 0.5. And in place of this z1, if it is minus z1, then our z can take any value between minus 1 to infinity. That is the area under the standard normal curve from minus z1 to infinity. It's minus z1 to infinity, and simplify this as minus z1 to 0, then 0 to infinity. And from the property of symmetry, we can consider this term as area from 0 to z1, and area bounded by 0 to infinity is 0.5. Since it is 0.5 plus a positive value, always the value is greater than 0.5. Based on these two terms, we can consider probability that z takes the value between minus infinity to z1. If value is less than 0.5, then we can consider our z1 as positive. If the value is greater than 0.5, then we can consider our z1 as negative. And I want you people to remember these terms. Then only we can solve the problem. If the problem is, in a normal distribution, 31% of the items are under 45 and 8% are over 64. Find the mean and standard deviation. Difference between the previous problem and this one is, in our previous problem, mean and standard deviation are the given data. By using that, we were finding P of X. But in this case, P of X values are already given for us. Based on these given values, that is values of P of X, we have to find out the mean and standard deviation of the distribution. Our X is the normal variate from the given data, that is 31% of the items are under 45, that is probability that X is less than 45 is 31%, or we can consider it as 0.31. Similarly, 8% are over 64, that is probability that X is greater than 64 is 8%, or it is 0.08. And when it is our normal distribution problem, always our first step is we have to change this to standard normal distribution by considering our standard normal variate Z as X minus mu by sigma. Now, when X is 45, our Z value is, here we don't know the values for mu and sigma. Let us consider as it is and substitute the value for X, that is 45. So it is 45 minus mu by sigma. For simplification, let us consider the term as Z1. And for X is equal to 64, our Z is 64, mu and sigma as it is. Sorry, instead of 64, here it is 8. Please consider it as 64. For our simplification, let us consider this term as Z2. And from the given data, probability that X is less than 45 is 0.31. Corresponding value for Z is Z1. So it is probability that Z takes the values less than Z1 is 0.31. That means probability that Z takes the value between minus infinity to Z1 is 0.31. And this 0.31 is a value which is less than 0.5. This already we have discussed. And when this value is less than 0.5, in this case, we can consider our Z1 as negative. And when Z1 is negative, this term is nothing but the area below the standard normal curve bounded by minus infinity to minus Z1. And when it is minus infinity to minus Z1, we have to simplify this as minus infinity to 0, then it is minus Z1 to 0. Whether it is minus Z1 to 0 or 0 to Z1, both gives the same answer. So it is 0.5 minus the area bounded by minus Z1 to 0 or 0 to Z1, or simply we can consider that as Z1. So A of Z1 is 0.19. And now from this, how to find the value for Z1? Already we know how to find the value, that is A of Z values, by using our distribution table. And here it is 0.19 in our distribution table, not in the first column and first row. In the remaining values, check where you can get 0.19. Here the value is 0.1879 and here we have value as 0.1951 compared to 0.1879. 0.1915 is nearer to our value 0.19, and this value is corresponding to Z is equal to 0.5 and here it is 0.00. I'll repeat. except this first column and first row. With respect to the remaining values, check where we can get 0.19. Here we have the value 0.1915. This value is for 0.5 and 0.00. So it's 0.5 plus 0.00, that is equal to 0.5. So when our Z value is 0.5, then we can get the area as 0.19. But our Z value, that's Z1 value, is negative. So let us consider this as minus 0.5, not just 0.5. And the second data given for us is probability that X takes a value greater than 64 is 8%, or it is 0.08. The corresponding value for Z is Z2. So it is probability that Z takes a value greater than Z2 is 0.08. And when it is greater than Z2, since it is a real variable, it is from Z2 to infinity. And now this value 0.08 is less than 0.5. And when it is less than 0.5, based on the note which we have already discussed, the value for Z1 is a positive value. And when it is a positive value, this gives the area under the standard normal curve bounded by Z1 to infinity. That is, first we'll find out the area from 0 to infinity. In that, we'll subtract the area bounded by 0 to Z1. And 0 to infinity, the area bounded by 0 to infinity is 0.5. And 0 to Z1, here in place of Z1 we consider it as Z2, since already Z1 is considered in the previous case. So it is A of Z2. And after the simplification, we are going to get A of Z2 as 0.42. And now to find this value of Z2, for which we'll get the area as 0.42, consider the table. And we have to get our answer as 0.42. Check where we can get 0.42. Okay, here we have the value. Here we have the value 0.4192, and here the value is 0.4207, and compared to this, 0.4207 is near to our value 0.42, and this value 0.42 is for Z is equal to 1.4 and 0.01. So it is 1.4 plus 0.01, which is equal to 0.41. When Z value is 1.41, we are going to get the area value as 0.42. And now by substituting the value of Z1 and Z2 in equation 1 and 2, we'll get two equations in terms of mu and sigma. And now by solving these two equations, we can get the values for mu and sigma as approximately 50 and 10. Thank you.